So thank you very much, and thank you for having me here at CyCon as a speaker. It's always a pleasure to come back to Tallinn and participate in a conference that is so well organized. So my presentation will be about monitoring the dark web for cybersecurity information, which is research we have been doing in Switzerland at Arma Swiss with some collaborators, which unfortunately are not all here, except Martin Strohmeyer, which is also here in this room, and is certainly happy to take questions also later on in the break. So the dark web is a conglomerate of services which are not directly accessible by search engines and also by regular users. The dark web is mostly used by criminals to exchange illegal goods. So, for example, to exchange illegal pornography, to exchange weapons, or to sell drugs. But the dark web is also used quite commonly by hackers and by cyber criminals to exchange information and trade information in the area of cybersecurity. So in the dark web, you will find a lot of information about vulnerabilities, software vulnerabilities, exploits, how to exploit those vulnerabilities. And you will also find information about data breaches. So there, I'm sure in this room, many of you have somehow their password of one of their online services that are traded in the dark web. So these passwords are traded. There is also botnets for hire, so services that can be hired and rented to launch, for example, distributed denial of service attacks. So it's certainly an interesting source also for the attackers, but the question in this research is to see how we could exploit this source of information for cyber defense to protect ourselves. So if we manage to observe what's going on there, we may have also an advantage at improving our cyber defense capabilities. So in the literature, you find different definitions of the dark web and the deep web. So these words are often used interchangeably. So in this work, we use a definition which is as follows. The deep web for us is basically a subset of the World Wide Web that is not accessible by search engines, but that you can access with a regular web browser over the HTTP protocol. And then the dark web is basically also a subset of the web that is not accessible by search engines, but there you need specialized tools and software to access the darknet over an anonymity network. So to access this anonymity network, there are a couple of technologies around, but the most famous technology is Tor. So the Tor project is a network of crowdsourced Tor routers that are used to build an anonymity network which provides peer-to-peer anonymity between clients and servers. In a sense, you can, as a client, you can connect to Tor. You will open up a virtual circuit of Tor relay nodes, and this allows you to access the regular web, but also to access Tor hidden services. So these services are basically only accessible through Tor, and as a client, you cannot see the IP address, and you don't know where the servers are, and on the other side, the server doesn't know who is accessing what is the IP address of the client. So there's been a study in 2016 to look at the size and how many hidden services there are around. So they found that there are around 30,000 hidden services that are available, that were available by then through Tor. So in a sense, the darknet is relatively small. If you compare this to the surface web, which has billions of sites, so it's a relatively small network. So the size is not the challenge in monitoring the dark web, but there are still significant challenges that arise if you want to systematically analyze and understand what's going on there. So here I've summarized the four main challenges that we have been addressing. So the first challenge is that there is quite a high service dynamics. So if you go in the dark web, you will realize that a lot of links and the services disappear after a while. So after a couple of months, you will see, and we discovered this also, that half of the services that were available at the beginning, they are no longer available. And this can mean that they are basically closed because of some legal reasons, or because they're just moving around to another link. So despite this dynamics, there's also the issue that the dark web is not well interconnected, hyperlinked. So if you look at the surface web, it's really a network. And when you want to monitor, you can have any entry point, and you can traverse this graph, and you will be able to find a lot of other sites. Whereas the dark web is more a set of isolated silos. So there is a study showing that 87% of the sites actually do not link to other dark websites. So it's more challenging to discover the services and to have some monitoring in such an environment. Also, there is the issue of languages, whereas in English is the main language for the standard language for security in the classical web. In the dark web, people use a lot their local languages. So you will find a prominent language which is Russian, but also English and other languages. They are used quite commonly. So if you want to monitor the dark web, you will need also to cope with the different languages. And then finally, last but not least, there is the issue that a lot of data is unstructured. So a lot of data in the dark web is found in forums in an unstructured way. So people just post something and then have there some information in text, and it's all distributed. So having a monitoring of such distributed unstructured data is also quite a challenge. So in this project, we set the objective to build a system that we call Black Widow. And the goal is to provide a user interface for cyber experts, cyber analysts, to capture the dark web dynamic in real time. What is really important here is to be able to find information quickly, because the darknet is typically the place where hackers and data leaks are traded in the first place. I mean, later on, they may appear also in the surface web, but at first, they always, or most of the time, they appear in the dark web. So it's important to have something that is relatively in real time in order to detect if some company enterprise has, for example, leaked password, that you realize it quickly, and then that you can take countermeasures. Then the goal of Black Widow is also to have some automation. Of course, you could analyze the dark web manually, but the goal of this system is to have as much automation as possible to collect the relevant data across the domain and across the language, to fuse it together and infer relationships between the actors and also between the leaks, and so to have a better understanding of the big picture. So here on this slide, I'm highlighting the overall architecture of Black Widow, which is basically inspired by the intelligence cycle. So the intelligence cycle is a recurrent model with 5 phases, starting with the planning and requirement phase, followed by collection, processing, analysis, and dissemination. So these are the 5 phases that can be used a couple of times to refine the search and to get more data and to make sense for the analyst. So what is the contribution of this paper and this work that we have been doing is trying to automate as much as possible these phases in the intelligence cycle to make this monitoring more scalable. So the first phase, which is planning and requirement, is difficult to automate, but all the other phases, the other 4 phases have been automated such that there is no need anymore for an analyst to basically do some manual processing, so everything is done automatically. So I will highlight a little bit each phase individually. So the first thing you need to do is basically specify as an analyst what is your interest, so which forums you want to focus on, and also to acquire access, because in the dark web, a lot of forums that are interesting, they require to authenticate, so there is access control. So there you need to get some credentials. Sometimes you need to just register and provide an email address. Sometimes there are systems that require you to buy some credits, or there are systems that require you to get some reputation and interact in order to get some access to the forum first. So, but as soon as you have this, then the idea is to have an automated data collection, which is basically some microservices which will open anonymous connections to these forums and start collecting data. There, the challenge compared to classical web crawling, basically these are web crawlers, and in that case we implement them to crawl these forums. The challenge there is that since you need to be authenticated, you often also need to to implement and to execute the JavaScript that is provided by these servers. So you cannot apply this classical crawling technique that are stateless and will just grab all the HTML. So basically what we need to do here is to have, what we did is a headless browser, which is basically emulating our user is browsing in the forum, and this way collecting information in an automated way. So we use the Puppeteer headless browser from Chrome, which is basically allowing us to do this in a reasonable amount of time. Then the next step is about getting the data. So basically what we collect is HTML data. So this is unstructured or structured in a sense with HTML, but what is interesting for us is the real content and the metadata of the things that have been discussed. So first we need to parse it and extract the information. But before we can really fuse it and make it usable, we need to translate it. And here we apply machine translation. So the idea is to collect the information from any language and then translate everything to English. This is the common representation language of Black Widow, where basically all information can then be fused in a common language. And then afterwards, when everything is translated, the idea is to extract information. So extract topics, extract text, and also authors who is interacting. Then the analysis part consists of inferring relationships. So there are a lot of relationships, but they are not direct relationships. For example, in social media, you have people following each other or people that are friends. These are explicit connections between the users in the community, but in the dark web, typically you don't have these explicit relations between the users. So what we need to do is to come up and infer the relationships, who is interacting with whom. And this is done by looking at the threads and who is posting and replying to each post. And by analyzing this information, we can actually build user relationships and try to understand who is interacting with whom and build a social graph. Also, we want to link data sources. So in this analysis part, we start linking data sources from the different forums and to build statistics to identify trends, also find hacks and leaks, for example. And then finally, the information is visualized and made available in the form of dashboards. It's also possible to produce alerts if certain things pop up, or it's also possible for the user to have queries specifying what he's interested in and what he wants to look for, so such that it has also a query interface. So at the heart of Black Widow is actually a knowledge graph. This is the brain of the system, because every information that we will make available to the user is represented in this knowledge graph. So this knowledge graph is a semantic model of the forums. So basically it models threads, actors, messages, and topics, things we find directly in the forums. But it's also fusing information that we infer ourselves with our algorithms. So for example, topics, we do some topic labeling and topic classification based on machine learning techniques. This is something we infer, and then we put in this knowledge graph. We also, for example, infer the language. This is also some information we put there, and so on. So at the end, we have a relatively large graph. Basically, represents all the information that we have gathered and fused from all the different forms in the different languages. So to evaluate Black Widow, we performed a study, so where we analyzed 7 forums that were available a few months ago. So 4 forums from the deep web, 3 forums from the dark web in 3 languages, in English, Russian, and French. As you can see, a couple of forums are no longer available. They disappeared. So a few months later, only 4 forums are still available. So this gives a first impression of what the Dark Widow was able to collect in a couple of days. So basically, we run this experiment, this study, for a couple of days and try to collect from these 4 forums as much information as possible. So depending on the forum and the size of the forum, we collected information about a couple of thousand to 68,000 users. And depending on the language and the forum, between 10,000 and 300,000 posts per forum. This is roughly the size of this forum that we were targeting. So the first insight that we can, an analysis type of analysis that we can do is inferring a cross-forum relationship. So here the question was to understand if there are, for example, actors that are active in different forums at the same time. So what we did here and what is plotted here in this chord diagram is basically the cross-forum relationship, and this is computed by looking at if there are users, usernames that appear in different forums. So if the same appear, then we make a relationship between the different forums. So what is kind of interesting here to note is that there are quite a lot of relationships, and we are pretty sure that, of course, the usernames in a forum can be ambiguous because there is no, it's not unique between the different forums. But the usernames that were used in different forums were usually quite distinct. So it's very unlikely that the person, 2 different persons were using the same username in a different forum. So it's very likely that it belongs to the same person. So what we see here, that across the same language, of course, we have a relationship, but it's also very interesting to note that we even have relationships across languages. For example, between Russian and French, also English and Russian. So it seems to be that there are some actors that are active on many platforms at the same time. So then this is another type of analysis that we can do with Black Widow, is to look at user relationships and communities within a forum. As I said earlier, we have an analysis phase where we infer the relationship. If you have a thread and you have a post there by a user that creates a thread, and then you have replies by other users, then if a user replies later on to this in this thread, we declare a relationship. So with that model, we then can create a social graph. And what Black Widow does, it applies some community detection techniques to find if there are communities. So here on the left, we see, for example, the communities that appeared in Forum 4. And on the right, in the Forum 5, we see the communities. What you can see here is that there are some, on the left, there are more smaller communities, whereas on the right, it's more fewer communities, but larger ones. Which means that on the left, these are people that are talking about, small communities talking about a specific topic, whereas on the right, it's more like one person that is disseminating information to a broad public. So with this type of analysis, you can then try to understand how information disseminates in the dark web. So here, finally, I've also here, I can show you what Black Widow can do in terms of trend analysis. So during these few days of monitoring, Black Widow was able to collect data from 2013 to 2018. So 5 years of data, which Black Widow can use to identify trends on specific topics. So what we can see here is a time series for botnets, databases, distributed denial service attacks, exploits, and leaks. Basically, this is what Black Widow has identified as a topic if a post is mentioning this topic. So what we can see here is that the trend, for example, for data leaks is increasing over time. So we have almost, in the last year, we have almost a 10-fold increase compared to the beginning. So it seems that there are much more activities across aggregated or overall forums on data leaks. Also, databases, the second most active topic, seems quite active. So exploits, it's a relatively constant trend over time. And distributed denial of service attacks and botnets, you can see that it's the lowest count. You can see a very large peak in 2016, which we analyzed in more detail, but we discovered that this peak is due to the fact that one of the forum was actually hit by a denial of service attack, and then people in this forum were actually talking about it, but it's not a general trend that there was more activities on sharing, also distributed denial of service or the botnet tools. Okay, so this brings me to the conclusion. So with this project, with this research, we have been able to show and to understand how we could use dark and deep web analysis, and especially to make the analysis more automated. I think that's what's especially important in this area. It's quite a complex environment, and we need, in order to make this scalable, we really need to have some automation tools. So we have found that it can be quite useful to monitor also the activities, but also to monitor the trends and to search with an approach like Black Widows. So we touched a couple of challenges, and of course we didn't solve everything, but at least we addressed some important challenges in terms of automated knowledge extraction, translation, relationship analysis across language barriers and forums. So it's also we were able to also observe within a couple of days of monitoring. We were also able to observe trends over the past few years. For example, the forums we have been looking at, we realized that leaks are becoming a crucial trend over recent years in the dark web, and especially in these forums, to share information and trade information about data leaks. So with that, I want to thank you for your attention, and I'm happy to take questions.
So thanks very much, Vincent. In fact, we have immediately one question in the front, and we'll entertain a couple more short questions before we move on.
A simple question: how much handwork is involved for each forum, or is it just press the button and get the pictures?
Yes, the pictures are computed automatically. So basically, everything is stored the graph is stored in Elasticsearch. So, and this allows you to build the dashboards and views and graphs. So this is basically automated. So, and everything, also the data collection is automated. So these are crawlers that crawl, extract information automatically, feed it into the knowledge graph, and then update it regularly to get a view of what's going on.
Okay, we have another question in the far right.
Thank you for your talk. To deliver and analyze information, you need to acquire it. And the challenge that I'm facing in the dark web is, and maybe you can explain how you did approach, how did you identify those 7 forums? Because identifying those forums might be a bit of a trick. How do you ensure that they actually deliver the required information that you would be making tangible? And also, how did you acquire access to them?
Yes, as I said, this is the only part. This is the first part. The planning and requirements is the first part of this intelligence cycle. This is the only part that is not automated. So basically, in order to find the interesting forums that are interesting for cybersecurity, there's still some manual selection process that must be going on. But because there are also a lot of forums or sites that are not related to security, and this you don't necessarily need to address.
Yes, that is correct. But I want to know exactly how did you choose them? What was your approach, not the theory around it?
Right, okay. So there are lists. There are basically wikis, a lot of wikis in the dark web, but also in the surface web, which list basically all the onion links. And then you can check them out. But these lists are usually very quickly outdated. So you will see that most of the links don't work anymore. So this is some tedious work to basically check and verify if these links are still working and if this is something behind it. Then what you can also do, and this is something that can be automated, is then to follow the hyperlinks from the forums that you're already monitoring. But as I said, the trend there is actually not to have too many hyperlinks. So this is not really a scalable approach. So you will find further interesting forums by following some links, but this cannot be the only solution.
Do we have another question on this side of the room that I missed? Okay, I think in order to keep on time, we'll thank Vincent again. And I'd like to invite Csaba Krasznai up and give us our last talk, after which we'll have some time for some overarching questions as well. So thank you.
Thank you very much. It's a great honor for being here and being the last speaker in this session, because my plan is to reflect to my colleagues and give some additional information for what they said, because we also have lots of experience in that field, because of the nature of my institute and because of the research, what I will talk about later. So who am I and what I'm representing here? I'm the program director of the Cybersecurity Academy at the National University of Public Service Hungary, which is the governmental university, and we are responsible for the education and of different officers, military, police officers, disaster management officers, and public servants as well. And we are also responsible for the research, what is important and interesting for the government, especially on the cyberspace now. And the Cybersecurity Academy was founded to somehow help this kind of research and educational activities. And why the cyberspace is important for the Hungarian government? Because it is important for the others as well. And they are interested in what really happens in the cyberspace, and they want to know whether they are attacked or not. And there are some organizations who wants to know who are behind the attack, what is the attribution. The others are just to want to know the fact that they are attacked and want to do something against them, against such attacks. And based on that experience and based on their needs, it seems that although prevention is still important, detection is getting on the peak. And I think most of you and most of us have understood that we won't able to prevent everything. Therefore, we have to detect such attacks. And in case of, well, state-sponsored attacks, in case of complex attacks, in case of attacks that are not made by ordinary cyber criminals, such detection is quite challenging. The technology, what we've heard, is quite good. But I can tell you that many times the attacks are not so sophisticated that it need to be. Because although we can buy some privileged access, some admin credentials on the dark web, in my experience in the last almost 20 years that I spent together with developers, I can tell you that the most common password for an admin or a root password is used to be A in test environment and development environment. Of course, there are so many legal or compliance requirements that tells that two-factor authentication is important, especially in case of privileged users. But trust me, in most test environments, A or password or 1, 2, 3, 4, 5 or similar are used to be used. And well, it's maybe acceptable if those servers are sitting somewhere behind in your data center. But as the cloud is emerging and we are now talking about DevOps, and we are talking about those guys who are developing the programs and then installing their servers into Amazon or Azure, and they are still using A for a password in such cases, or they even write their credentials, they are hard-coded their credentials into source codes that are uploaded to GitHub. I think it's getting serious. Therefore, those admin credentials will be used in one step of a direct or a targeted attack. And I think most of you are already familiar with this picture. That is the cyber kill chain model from Lockheed Martin from 2008. And that tells that the first step is used to be the reconnaissance part. Finding those persons, finding those users who will be the target in a targeted attack. And it's fairly easy nowadays because just buying a data set from the dark web can help us to find those users who might be privileged, and their account, their credentials might be used to access the servers. And for the second part, for the weaponization part, we can also buy several 0 days, but based on the experiences, 0 days are rarely used because the open source, the freely available tools can be used for directed attacks as well. The second picture is made from the attack matrix for enterprise. This is the attack framework from the Mitra Corporation, and that shows the usual steps of a targeted attacks. And somewhere in the middle, we can see the privilege escalation and the lateral movement parts. So yes, we are talking a lot about what happens if an endpoint is attacked, what happens if our Windows client is, for example, infected by a malicious code, but sometimes in the middle of an attack, the attacker wants to move further and want to get a privilege access, a privilege account, and wants to find the really interesting servers in the network architecture. And they will find, but how? I think the SSH part was quite interesting, especially for the ICS SCADA systems, because Shodan.io is a very good source where we can find that still lots of SSH access are open on the internet. But nowadays, RDP and PowerShell is the most widely used attack vectors in case of lateral movements. And I would like to emphasize the next big steps, the APIs, because as more and more IoT devices will be planted into the network, the API communication will be, I think, the next huge threat for the directed attacks, targeted attacks. Not to say that as I mentioned, I think there are lots of common tools and freely available tools that can be downloaded from the internet, and those are widely used in state-sponsored attacks as well. So in last October, the US Department of Homeland Security has released a very interesting announcement, this alert, on the publicly available tools seen in cyber incidents worldwide, and they mentioned 5 tools that are commonly used in state-sponsored attacks. And the last 3 the credential stealer, Mimikatz, the lateral movement framework, PowerShell Empire, and the C2 obfuscation and exfiltration HUC packet transmitter. That is why I highlighted those 3 tools, is the reason that they can be used to steal the privileged credentials inside or during a targeted attack. I think from those tools, the Mimikatz one is the most interesting one, as that tool was used for NotPetya as well, and its direct goal is to steal the privileged credentials from the memory of the infected computers. Why is it important? Because if we have the privileged account from the memory of a computer that might be connected to a network that might contain, for example, a domain controller, of course, we can, or the attacker can move further and can hack the domain controller as well, or several other servers as well. And why I highlighted the Mimikatz one? Because a lot of state-sponsored groups, or who are attributed as state-sponsored, have used that tool before in their attacks, like APT1 that is attributed to China, or APT28 that is attributed to Russia, or the Lazarus Group, which is attributed to North Korea, and not to mention NSA, because I think the Mitra Corporation is not mentioning the NSA in these groups. But I think they are also might use at least one part of the Mimikatz, because it's a very useful tool, and this works since 2007 or something, so it can be very, very useful. The problem, the time. Maybe most of you are also familiar with this Verizon data breach report and with this figure from the data breach report. And why I highlighted this one is the reason that we don't have time. Therefore, we need something that can help us to identify the attacks in time. Just one example. A month ago, a small Hungarian cloud provider has been hacked, and a few thousand credentials were stolen from their servers. In 3 days, the whole data set has appeared in a dark web forum, in a Russian dark web forum for $200, so fairly cheap. But as that data set contained directly Hungarian interesting credentials, that might be interesting for those state-sponsored groups who are targeting the Hungarian companies or Hungarian organizations as well. So right after the hack, in 3 days, there were the whole data set. And the problem is that although that organization was made a good job and they identified the attack just in time, in many cases, and based on our interviews and our researches, the reason is that we are not able to identify the data breaches in time, in days. The first time when we realized that we were hacked as when the data that was stolen from our organization appears on the dark net. So, or someone just tells the local data protection authority that his or her data is on the dark web. So maybe months or even years right after the hack, we can identify the fact that we were hacked. So we don't have time. We need to do something. And now I'm turning to the research part, because the research what we made is has tried to give some ideas that how the machine learning can be used to help reducing the time, and which are the major problems to identify the stolen privileged accounts. That research was made by my university and the Budapest University of Technology and Economics with the Department of Ergonomy and Psychology. And that was an industrial project, what we made together with the Hungarian development branch of One Identity, one of the leading developer of privileged access management. And what we tried to understand is how the current security operations centers are focusing on privileged accounts. How can they solve the problems of privileged accounts? So just a few words on the research background. That was a larger security operations center research. We made many interviews on the field. We visited several security operations centers, but not just in Hungary, but in Europe and in the United States as well. We also made interviews with key industry analysts. Of course, we had a lot. So I think that what I will tell you is kind of a state of the art now. And we had a lot of hypotheses, but now just focusing on the privileged users. One of our hypotheses was that the protection against the privileged account hijack is a major concern for them. That was one of the major research questions. And what we found is two types of security operations centers. First of all, the large security departments with integrated security operations have a well-resourced major security operations center in place. And more security operations centers are operating worldwide. Maybe they are now called fusion centers. Maybe they are still using the name CCERT, or they are just a CERT. So I don't want to go into the abbreviation war what we had during the research. Let's call them security operations centers. But although there are thousands of well-resourced security operations centers worldwide, most of the companies and most of the organizations are still struggling with the problem that they have small security departments with lack of resources, with no security operations center, with no or limited SIM, and of course with no capability to identify the potentially stolen privileged accounts. I don't want to be nor the pre-sales engineer, neither the data scientist of One Identity, because I'm the cybersecurity guy from the university. So I didn't want to tell the details of the technical part, but as based on your questions you are interested in, I want to highlight some very interesting results from the research and from the product development. First of all, the hypothesis, the sixth one in this research, was that understanding the attacker's behavior is important, and that was confirmed based on the interviews, because as you you mentioned that the usage of the honeypots are important because we need real-time data. We need some real-time real activities, real-life activities. The Security Operations Center analysts also need the real-life examples. But unfortunately, the honeypots couldn't be so real-life. And of course, from the internet, we are not able to download data sets that can help us to understand the real activities. Therefore, if we somehow can help the analysts to provide the real-life examples of data, what the state-sponsored, mainly the state-sponsored attackers are doing, that can help a lot to fine-tune the prevention part of the companies. This next hypothesis was that the privileged account monitoring is challenging. That is plausible. I would say that from the technological part, the SSH is one that can be fairly easily analyzed. And through SSH, we can fairly easily see what the privileged users are doing. So it's kind of an easy protocol. But for example, in RDP or in PowerShell, which are widely used among the privileged users, it's a bit challenging, especially in PowerShell. So from the research perspective, I propose to move to the PowerShell part. I think that's quite interesting. And the next hypothesis was that the user behavior analytics is useful. So the machine learning, implementing machine learning into that part is also something that might be useful. And I can tell you that the user behavior analytics is really working. So the technology itself is quite useful. So the company could develop a lot of user behavior machine learning analytics to both the SSH and to the RDP part. And with the help of machine learning, they could identify both the outliers, they can differentiate the human activities from the machine activities. They could also help they could also develop biometrics, behavioral biometrics, both on the keystroke and the mouse movements. So I think that the user behavior analytics and the machine learning could be the real solution for the identification of such attacks. Why? Because we have problems. Because in real life, in a Security Operations Center, there are too many alerts. Good. Because, the theme is like this, too many alerts. But the lack of human resource to process them is something that is a common daily problem for most of the SOCs. Simply, we don't have enough analysts. We don't have any people. We don't have any human. And that is why we came into the picture in this research, because we have some young cadets on my university, some future officers who will serve in the Hungarian Defense Forces, someone who will serve as cyber warriors, cyber experts in the military, and they will go to the MIL-certs. Therefore, we sit them in front of this SIM system or this user behavior system, and we wanted to understand how the young cadets are reacting to the problems, how they can identify the stolen privileges. And I can tell you that from the user experience part, this is a bit challenging, because in real life, privilege escalation and lateral movements rarely happen. It's not something that is a daily problem. Yes, cyber criminals are in the networks on a daily basis, but state-sponsored attackers rarely appear in most cases in most of the organizations. So from the UX part, the major challenge was how to help the cadets, or in general, how to help the security analysts to identify that this is not a false positive, this is something that needs to be clarified. Because high-profile attacks remain uncovered in the huge load, therefore it's very tough to identify them. So, so machine learning can be very useful there for them. But for a successful machine learning, you have to have a baseline. But if you want to have a baseline, you have to follow the users, follow the real human users. that raises some privacy questions. And in Hungary and in general in Europe, we have to keep in mind privacy as well. So that the technology is there. Unfortunately, it seems my slide is a little bit well, changed. But in the hype cycle of Gartner in 2016, you can see machine learning and software-defined security on the peak. In 2018, those two technologies has been disappeared from this list because they are now the reality. They can be used in the security as well. And there are more and more products that will appear in your organization, I think. The vendors will knock on your doors with that technology. So you can use it. But the question is, what is your goal? Is it useful? What should we do? Should we catch the next Manning, the next guy who is sitting next to a computer with some kind of credentials? Should we catch the next Snowden with high-profile access, with a high-profile account in the organization? Or should we catch the external attacker who will steal the Snowden-like credential from, for example, a data breach, and who will play or who will do the stuff inside the organization like Snowden did? Who knows? What is your goal? You have to decide it. But as the conclusion, I would say that in general, the passwords are dead. What we told, I think, 10 years ago, 20 years ago, but they are really dead. So we have to find a new technology, or if we have to still live together with passwords, we have to find new technologies that will help us to identify the potentially stolen passwords or credentials, and machine learning will be that tool, I think. Thank you very much for your attention, and I'm open for the questions.
Thanks very much, Csaba. Very nice that you actually tied things together as well. So let's go around the room for some questions. We have someone back there.
Hello again. How, and maybe not only for you, but for everyone here, how are you confident and how are you going to get large data sets of targeted attacks? Because there are not a lot. There's a lot of noise, and noise is ransomware or just the stupid attacks that are very easy to detect and to prevent. But machine learning needs a huge amount of data. Targeted attacks, when you're lucky, you see one in a period of weeks or months. If you are not lucky, a little bit more. But don't expect a lot of dots on the radar. How?
I agree with that. So as I mentioned, I'm not nor the pre-sales, neither the data scientist, but I can tell you what was the solution for that in our case. So in our case, and that is why I highlighted the middle of the targeted attacks, because if we know that how the administrators are used to work, what is our ordinary keystroke, mouse movement, commands, applications that they are open through RDP, we can have a very confident baseline of their usual activities. And we can, with this machine learning algorithms, we can identify the potential anomalies, which are not similar to their daily job. And we can highlight, we can notify the analysts that, hey, there might be something that you have to keep your eyes on, and please just follow that remote session and see what happens inside, because that might be an attack.
I'm very glad, actually, that the question asker also mentioned this could be for other people as well. So feel free to jump in, both Pierre and Vincent, if you have something to add to this. Another question, perhaps from this side of the room, has been somewhat less inclined question-wise. Anyone over that way? Okay, let me pose then, one of the several questions that I've collected along the way. So one of the things that you didn't mention, but is absolutely true, is of course many places are trying to move towards zero trust networking or something like that. So of course this move to the cloud in many cases means that no longer do you have systems hidden behind firewalls in any case. So I think this is a universal problem regardless of whether people go to Azure or AWS or something else. Now back to the machine learning approach and, for example, this question about how to get enough data. In fact, all of you face these kinds of issues. Does it not make sense to simply collect a lot more data from cyber ranges or from exercises like locked shields? Where in a sense these are generated by friendlies anyway, so there may be some bias issue, but this is perhaps a prime source of data.
I can take over because I was also doing the work that was presented yesterday on how to use data from locked shields to basically train a classifier in order to detect attacks. I think, and it goes also into the first question. I think machine learning, it's true, it can only be used to detect and train classifiers to learn what we have seen in the past and to try to automate the detection of things that we know. So if we can assume that the attacks is repetitive and it happens a lot of time, then I think machine learning is a good tool to automate the search for this type of anomalies or attacks. Whereas if you expect to have an attack that is new, has never been performed before, I think machine learning is not the right approach to take. So there we need to have other type of techniques. So basically it depends on what kind of attacks you're trying to prevent. In locked shields, this is a kind of repetitive environment. It happens also every year, as we have seen in the presentation yesterday. It is possible to infer from 1 year, train a model, and the model will be valid for the next year. But if you go to real life and you have a very targeted attack, a determinate attacker that really wants to evade all this, then of course machine learning comes to its limitation.
Indeed. And so I don't want to take us too far down into machine learning, but maybe it's something else I could then ask for your comments on. One of the things is that we very rarely hear people discussing a full diversity of machine learning. So there's, of course, deep learning and artificial neural networks of various kinds. There's machine learning as we've discussed it today. There are also other approaches which are more glass box machine learning, considerably less popular than these other ones, but ones in which you can artificially structure the knowledge graph, actually it starts to look like, pre-structured, and then use supervised machine learning to refine it. Do you see this kind of initial brain dump from an analyst and then some supervised machine learning as a potential approach or solution to what you just mentioned, or
Absolutely, because I think that machine learning is basically learning from data, but you can also build artificial intelligence systems where you don't learn from data, but you learn from the expert. And this is probably the way to go, because we have experts, they have some knowledge, they may know what to expect, and it's possible to build models that will be then not learning from the data, but basically the experts we have, yes.
Yeah. So I'm very sure that people don't want to just hear my question, so please let's have a show of hands if there's anyone with a latent question that you'd like it answered. Otherwise, I will jump in with one more of mine, with apologies. And then, sorry, Vincent, sorry to pick on you again, but one thing that struck me is maybe if you look at the work that Pierre's been working on, there's surely a whole bunch of bits and pieces inside Black Widow which are then directly applicable here. This is one style of machine learning, but for example, these other correlation techniques that were used to detect the communities, those are in some way usable for kind of time correlation or identifying communities that are actually carrying out a concerted attack, maybe through several different SSH sessions, which is, as I understand, not really possible right now with the current approach, but maybe you have some comment about how this could connect or be extended, even though it's a very, very different tool.
I think if you want to do cyber defense today, you need to have a lot of sensors, a lot of monitoring systems, and it's also all about data fusion and trying to combine information from many different sources. So what I presented today about Black Widow is basically monitoring the dark web, which could be an interesting data source to find some data that is leaked or vulnerabilities. But then you will have also maybe your honeypots that are there, and then they will also collect information about what hackers' trends are going on. Then you will also have your security monitoring systems. One of it could be what Pierre has presented, monitoring the SSH activity. And basically you have to come up with all this information and try to make sense of it and fuse it and basically exploit everything you have. So I think that's the way how to go. So it's not possible to have one approach and focus on it, but we really need to take all the opportunities, open source information, information from our own security systems, and try to build intelligence out of it. I think that's the way to go in the future.
Indeed, indeed.
Yeah, and I entirely agree with Vincent. In my job, we have our SOC, and during my day job, I try to enrich the data that our analyst receives. So with open source intelligence, with any help that we can provide them to help them solve cases faster. Because in the end, that's what the main performance you want to improve with your security analyst, is how many cases then they can solve, because the number of cases will only increase with the number of clients that you have. So you really have to improve the performance of your analyst by helping them with open source or data from the dark web that can tell you, oh, look, today we saw in our dark web analysis that they are talking about this recent exploit. Or, yeah, for example, in Hansen, we saw those commands. We can infer with the help of a machine learning tool that is probably malicious because we already saw that previously.
Indeed, indeed. Okay, and then one last question, if I can direct this at you, you Pierre. Of course, many of these techniques in n-grams are taken from computational linguistics, natural language processing, and you may know that over in that world, there are also approaches where the n is not fixed. So you have a dynamically sized window for the generation of these n-grams. Have you thought about using that? That's a potential solution to the fact that the attacker can flood things and then make you use a larger n to the detriment of the system as well. So a kind of elastic approach to this might be...
Yeah, sorry, I wasn't entirely clear with this. But yeah, we're not using just the 1 grams or the 2 grams. We're using a combination of those. So if we say,
right,
we take, for example, up to 3. So 1 grams, 2 grams, 3 grams.
Right, right. Very nice.
Because, yeah, the different sizes influence on what information is put in advance. With the 1 gram, you would see which program is used often.
Exactly.
With at 3 or more grams, you would see previous and next commands, which are grouped together.
Indeed. So, Java, I'd like to just thank you for tying it all together. Very much appreciated. Vincent and Pierre, also very much appreciated for your technical contributions leading up to that. And I have also the speaker's gifts, if I can give those to you, and we'll thank them in just a moment. Whoop. Thank you.